Great. Now that we discussed shortcuts, let's now just put one last addition to this. And it is essentially to code the transformer block itself. Um, this, as you know, it is one critical part of the of a GPT model. So let's build the transformer block. This is what is repeated a couple of times. I think in the GPT-2 in the GPT-2 model, it is repeated. In the small one, the 124 parameter one, it is repeated about 12 times. So let's see what it looks like, and then we'll look at how to connect it to the overall GPT model, and we'll be done. So we've actually discussed what is important here, the several concepts that are needed to make this block. We discussed multi-head attention, we discussed layer normalization, dropout, feed forward layers, and GALU activation. So now let's put all of those together. Imagine that we have an input. Remember our input. So I'm going to scroll down because I'm not sure how much space I need. So imagine when we had that input, we had input like s- step every step, every effort, every effort, not every step, every effort moves you. That's the one that we want. That is the input. We want it to predict forward or something, right? So now that we have this, we are going to they are going to be tokenized, right? These words are going to be tokenized in some special way, and then they're going to be embedded. So let's create the embedding. So imagine our embeddings is going to be this. So this is the embedding for the first one, 2961, all the way up to 0.4604. This is the first one embedded, 0.2238, all the way up to 0.7598. And then this is the third one, 0.6945, all the way up to 0.5963. And then the last one will be embedded into this 0.5833. And we know that these say 700, each one is 768 dimensions, because that's the embedding dimension that we're doing, right? So as that is our embedded input, this would then come into our block, our transformer block, right? And what it first gets to, we normalize it. We are going to first normalize it, and we are just going to call it layer norm 1. So that is the first normalization that is happening. And after it has been normalized, mean equal to 0, variance equal to 1, what then happens next is we are going to put that into the masked multi-head attention block. Attention here. So there's going to be multi-head attention that happens. And after masked attention happening there, we then do apply dropout. We then apply dropout. All the while we're doing this, we are going to actually have here a shortcut. We're going to have a shortcut that goes like this to here. Perfect. So that is going to be our shortcut. And what comes out of dropout is then this is now added. This is now added through the shortcut. And we are going to have layer normalization 2. Normalize it again. And after we normalize it again, we will then pass it into the forward, feed forward, those feed forward layers that we discussed. And then we apply dropout again. Going to apply dropout again. Great. And then before we get to output, what we're going to do is here we would have done a shortcut as well. So there's another shortcut there. So all this that we've just discussed, so it goes out like that. All this that we are building here, all this I'm going to wrap it around like this. This is what is called the transformer block. So that is our transformer block, and that will be repeated in our 124 parameter model. This will be repeated 12 times. So that is the transformer block. Outside everything here, including the embedding, that is the GPT model. But for now, we're just focusing on the transformer block itself. So let's see. We can, for our feed forward, we are going to have a linear layer, a linear layer here. Going to have GELU activation, GELU, and another linear layer. And this part will explode the dimensions, because this will be 768. It will explode it times 4, then this will shrink it down back to 768. So that is what we are now going to see in code, because we have discussed the principles already. Let's now just apply them in code so that we come up with something like this. Let's see. Shift to our Chrome. So in our Chrome, we are going to have that. Remember, with the multi-head attention, we discussed this previously. So we are just copy pasting and bringing it here. So this is just multi-head attention with its forward, and that's it. Calculating the attention weights with our softmax and all of that. You can go back to see how we calculated our KQVs and all of that. We did that already, and we get our context vector. So now in our transformer block, like we said, we are going to have the embedding dimension, and the out will be embedding dimension. So this is actually a very, very deliberate and a crucial part of the design of of this transformer network. This preservation of shape throughout that transformer, it is crucial in its design, because it enables our application to work across a wide variety of wide range of sequence to sequence tasks, where each output vector directly corresponds to an input vector in a one-to-one relationship. Remember, we're calculating our output is a context vector, which encapsulates information from the input text, the entire input text, like we saw here. This entire input text. So although that physical dimension of the sequence is like, but we're having the same 768 and 768, the meanings of the what comes in as embeddings and what comes out is completely different. Coming in is the embeddings, and then going out, even though they're 768, it will be the context vectors themselves. And each context, so it'll be context vector for each input vector, where we have encoded and integrated contextual information across that input sequence. So that's what will come out, but it will have the same dimensions. And we have our context length, number of heads that we are going to have, our dropout factor, and all of that. We have seen this before. This is not surprising. We are now putting everything together. Remember, we created our feed forward class. We are applying it here. We created our layer normalization class. We are applying it here. Layer norm 1, layer norm 2, and then dropout. Just create our dropout there. Perfect. So in our forward pass, we are going to create a shortcut here, which is our first shortcut, right? We have the first shortcut, which takes in the embeddings. So here we're just saying what comes in first. We're creating a shortcut. We're putting it on the side, and then the X that comes in gets normalized. We said we are going to normalize first, and then we apply the multi-head attention on that X, and then we apply dropout. And then we said we are going to get a shortcut. So we apply the shortcut here. So the current X that is there, plus the shortcuts that we put on the side. That's just here to create a new X. And that new X is now added on the side as a shortcut that then goes on the side as a shortcut. And we apply normalization again. Then we apply the feed forward network, then, which is your layer number one, GELU layer number two, gets exploded during GELU and then gets taken back down because our FF, you remember, this is our feed forward. And if we go back a few videos back, we did discuss this feed forward. And then we apply our dropout and we did then apply the shortcut again. We add the shortcut and that's it. So this is just it. This is the transformer block right here. That's the transformer block right there. So if we are to see that it actually returns the input and the output shape as the same, imagine we have this a batch size of 2 with number of tokens equal to 4 and embedding dimension 768. Let's apply that transformer block. So our block is just going to be transformer block. We put in our GPT configuration so that it picks up all these, the embedding dimension, context length, number of heads, and all of that from our configuration dictionary, and we output when we apply, we get the output. So the input shape is just going to be the same as the output shape. Although the output will be different, the output again, it means something different because of the multi-head um, attention here. We are outputting context vectors and all of that. It has different meaning, but it will just have the same. It will have the same dimension as we can see here. So our transformer block, I think, is ready. I think it is ready. In the next video now, we are going to connect this transformer block into the GPT model because you remember the GPT model includes the embedding itself and all of that. So we are going to now put everything together into a GPT model. Now we can hold the GPT model in our hands. So let's see what the next video is going to have.